Hi, this is Ms. Benson with SanfordFlipMath, and today we are working through the second part of section 15.3 or lesson 15.3 in the Springboard textbook for Algebra 2. And this time we're talking about dividing using synthetic division. So last video we ended up here. We did a whole lot of work to end up with this quotient here when we divided our two polynomials. Okay, so we're going to do the same thing but using a different method. This is called synthetic division. So with synthetic division, you can only do this, it only works when the divisor, or this guy, what you're dividing by, okay, is in the form x minus k. That's how they write it in the book. Okay, x minus and k here. K is just some constant. Okay, so that means it can either be x minus something, as it is in this case, or it could be something like x minus a negative k, which would then make this an x plus a constant. Okay, so if our k is negative, then our k can either be negative or positive, so it can either be like an x plus c or an x minus c, and those are the only times when we can use the synthetic division. So we have an x minus a number, so we're going to use that. So what we need to do is we're going to make a box. Okay, I'll set this up in black. Okay, we're going to make a box. I'm going to draw a line underneath it. What's going to go in this box is our k, or you can think of it as the opposite of this number. So we have an x minus 2. I'm going to put a positive 2 in that box. Okay. Then the other thing that I need is all of the coefficients from this polynomial function, what I'm dividing that divisor into. So I'm going to take all those coefficients. So I'm going to do -5, -2. Now I don't have an x cubed term, so my coefficient for x cubed is 0, 32, -48, and +32. Okay, those are all of my coefficients. Okay, so now what I need to do is, my first step is to bring this first coefficient down. And I'm going to write it underneath the line. Now why is that? Now what we're going to get here is are the coefficients of our quotient. Okay, I'm going to write that as coefs of the quotient. Okay, so coefficients of our quotient. Now when we divide any polynomial by something with just an x with no other coefficient in front of it, like we did here, what ends up being part of our quotient is that -5 from whatever we're dividing into ends up as the first coefficient of our quotient. So we're going to, since that's the way this is always going to go, is we're dividing by something that's in the form of x minus k that has no coefficient in front of the x, we're always going to have that first coefficient come down. That's always our first step. Then the next thing we need to do is multiply this number by this number. Okay, I'm going to multiply those, and I'm going to put that answer here. So -5 times 2 is -10. And now I need to add these two numbers. Okay, so I'm going to add -2 and -10 to give me -12. Okay, now last time we were making everything the opposite, and then we were adding, or in other words, we were subtracting. But since this number here is positive when our 2 up here is negative. Since this is already the opposite of this, that's why we add instead. Okay, so our main steps here is we multiply, and our second step is that we add. Okay, so just to help keep those two things straight. Okay, now we're going to do the same thing with this one. So negative 12 times our 2 is negative 24. So I take my negative 24 plus 0 now, and I have a negative 24. Okay, now negative 24 times 2, negative 48. So I add my 32 and negative 48, and I get negative 16. I've got negative 16 times 2, that's a negative 32. I add these two, that gives me negative 80. Negative 80 times 2 gives me negative 160. And I'm going to add these two now. 32 minus 160, or plus a negative 160, gives me a negative 128. Okay, now this last number here, I'm going to draw in a little line there. That last number there is always going to be our remainder. Okay? Okay, so I said that that last box there is going to be our remainder. Well, what do the rest of our numbers mean now? Okay, so let's make this into something that's understandable. So what I already set up here that what we're getting down at the bottom are the coefficients of our quotient. Okay, now if we have an x to the 5th divided by an x, even though we don't know all the, all the nitty-gritty details of all of it, we know that since we're dividing these two polynomials, we're going to end up with something that's x to the 4th. Okay, so that means we're going 1 degree down of what we had. So that means that our quotient is going to be negative 5. We're starting right at the beginning of that x to the 4th. Negative 5 times x to the 4th minus 12x cubed minus 24x squared minus 16x minus 80, then plus our negative 128 over x minus 2. Because even though we're using only 2 up here all the time, what we're really dividing by is still our x minus 2. Okay, so this is our quotient. And now does this, I wonder if this matches, because this was the same thing we did last time in our long division video. So does this match what we got before? Looks pretty darn close. So we should be getting the same thing as we did before. And you know what? I missed a negative here on that last video, so I'm going to correct that here now. Okay? All right. So this is called synthetic division. And again, let's remember that we can only do it when it's in the form of x minus k, or we're either doing x plus a constant or x minus a constant, and we're using this basic formula. Okay. Now let's try it again with something different here, okay? So finding the quotient using our synthetic division, we're going to make a box here, draw my line. In this box, I want whatever my k is. So if it's in the form of x minus k, that means that k equals 4, or the opposite of whatever you see in the box. So x minus 4, I want a positive 4 in this box. Okay, and then I want all my coefficients from this polynomial. So I want 1, negative 2, negative 15, 31, and negative 12. And luckily I'm not missing any terms here. Okay, now I just need to use my basic formula. So the first thing I need to do is bring down that first coefficient, so I get a 1. And I'm multiplying my 1 by my 4. And then that is going over here. That gives me a positive 4. Okay, then I add these two together. Negative 2 plus 4 gives me 2. Now I'm going to do 2 times this 2 times my 4 is 8. Add these together, gives me negative 7. Negative 7 times 4 is negative 28. Add these together, gives me 3. and 3 times 4 is 12. Add these together, that gives me 0. And I'm remembering that that last number is going to be my remainder. Okay, so let's make this into something meaningful. So my quotient here is, when I divide those two polynomials, okay, now I'm dividing an x to the fourth by a polynomial that has the greatest degree of, that's first degree. So a fourth degree divided by a first degree is always going to be a third degree. So we are going to have the coefficient of my x cubed is 1. Then I have plus 2 x squared minus 7 x plus 3. And then I have a remainder of 0. So I can write this as plus 0 over what I'm dividing by, plus 0 over x minus 4. But that just ends up being 0. So I can just say plus 0, or I can just leave that off. So my quotient, as simple as possible, is just x cubed plus 2x squared minus 7x plus 3. And since I have a remainder of 0, that means that this polynomial is a factor of this polynomial in addition to that x minus 4. Okay, both of those are factors. Since I have a remainder of 0. Okay, that's just another little tidbit to throw out there. We have two factors. Now let's do a couple more examples. Let's look at this one. So find the quotient using synthetic division. We are dividing by negative 2x plus 3. Wait a minute. This doesn't match. So this one doesn't match our model of x minus k. Okay, it's not x without a coefficient. Our coefficient here is negative 2. And plus 3, that would be fine, but that negative 2 throws us off. So we can't do synthetic division with this example here. So just to show you what we can and can't do it with, you have to make sure that you can distinguish one and between one and the other. Okay, and you can see that doesn't work because before, when we bring down our first coefficient, this one doesn't match this one here. Okay, and that kind of throws off our whole system of what we do when we do synthetic division. So that's why it doesn't work. Okay, now let's do one more example of using synthetic division. So I'm going to make my box, and I'm going to draw my line underneath. And here I need to have all of my coefficients and figure out what goes in the box. So what goes in the box is the opposite of what I have here, or so that's going to be a negative 3, since I have a positive 3 there in my divisor. Okay, and then I need all of the coefficients in addition for all of the terms from the 4th degree all the way to the 0 degree. So I have x to the 4th has a coefficient of 1. X to the 3rd, or x cubed, is not present here. So we're missing x cubed, so that needs a coefficient of 0. Okay, then the coefficient of x squared is negative 13. I don't have an x term here, so that also has a coefficient of 0, because 0 times x would make that disappear from our polynomial here. And then 32 is our constant term. All right, so now we have to do our basic processes before. So you might want to do this on your own. Take a minute, pause, try it on your own, and then we'll do this one together. You can check to see how this goes. Okay, so we bring that 1 down, that gives us 1. 1 times our negative 3 goes over here, that gives us a negative 3. 0 plus negative 3 is negative 3. Negative 3 times negative 3 gives us a positive 9. Add negative 13 and 9, that gives us a negative 4. Negative 4 times negative 3 gives us a positive 12. add my 0 and positive 12. That gives me 12. 12 times negative 3 is negative 36. Add these together, I get negative 4. And that one is my remainder. So again, let's think what are we dividing? What degree polynomials are we dividing? So I'm dividing a fourth degree polynomial. So I have a fourth degree is being divided by a first degree. And when we divide, we subtract our exponents. So that's the reasoning behind why an x to the fourth divided by an x, or an x to the first, is some sort of an x cubed polynomial, because we subtract our exponents when we divide our polynomials out. So our coefficients of our x cubed, we have x cubed has a coefficient of 1, and then x squared has a coefficient of negative 3. My x term has a coefficient of negative 4, and then my constant is 12. And then I have my remainder of negative 4 divided by x plus 3. Don't let this throw you off. You always want to divide not just by your negative 3, even though that's what we're using throughout. We always have to go back up to our original and put everything in terms of our polynomials and what we're actually dividing by. Okay, so there you are. There's our last example of synthetic division. So these are just a few more examples. Make sure that you practice, when you're practicing these, make sure you're paying attention to why we can use synthetic division, when, and just the basic process. Multiply and add. Don't let that confuse you from our long division. Thanks for watching. We'll talk to you again later. Bye.